Hello everyone, I am ASHA is studying second year MSc in Computer Science at Manasa Gangotri, Mysore. Today I am going to present the topic that is Supervised Learning, Classification, Regression, Types of Regression. Let us try to understand what is machine learning. Machine learning is an application of artificial intelligence that provides the systems the ability to automatically learn and improve from the experience without being explicitly programmed. Machine learning mainly focuses on the development of an computer logical programs that can access any data and use it learn for themselves. Some methods of machine learning: supervised learning, unsupervised learning, semi supervised learning, reinforcement learning. Supervised learning. This algorithm contains a target or outcome variable which is to be predicted from any given set of predictors. Using this set of variables, we can generate a function that maps input to a desired outputs. This process stands until a model achieves a desired level of accuracy and a training data. For example, regression, decision tree, random forest, KNN, logistic regression, etc. Advantages of supervised learning. Supervised learning allows you to collect data or produce a data output from the previous experience. Helps you to optimize performance criteria using experience. Supervised machine learning helps you to solve various types of real-world computation problems. Disadvantages of supervised learning. Decision boundary might be overtrained if your training set which doesn't have example that you want to have in a class. You need to select lots of good example from each class while you are training the classifier. Classifying big data can be a real challenge. Training for supervised learning needs a lot of computation. Unsupervised learning. This type of algorithm we do not have any outcome variable or target to predict. It is mainly used for clustering population in different groups, such as widely used for a segmenting customers in different groups for a specific intervention. For example, a priori algorithm K-means. Advantages of unsupervised learning. The number one advantages of unsupervised learning is the ability for a machine to tackle problems that humans might find either due to a limited capacity or a bias. Unsupervised learning is ideal for exploring raw and unknown data. Disadvantages of unsupervised learning. You cannot get precise information regarding data sorting and the output as data used in unsupervised learning is labeled and not known. Less accuracy of the result is because the input data is not known and not labeled by people in advance. This is the diagram for supervised learning and unsupervised learning. In this, the supervisor will train up the machine to label the given data. But in unsupervised learning, it doesn't label the given data. Semi-supervised learning. Semi-supervised machine learning algorithms fall somewhere in between supervised and unsupervised learning, since they use both labeled and unlabeled data for training. Typically, a small amount of labeled data and a large amount of unlabeled data. The systems that use these methods are able to considerably improve learning accuracy. Reinforcement learning. Reinforcement learning describes a class of problems where an agent operates in an environment and must learn to operate using feedback. Types of supervised learning. Classification, regression. Classification. In machine learning, classification refers to a predictive modeling problem where a class label is predicted for a given example of input data. Example of classification problems include: given an example, classify if it is spam or not. Given a unwritten character, classify it is one of the known characters. This is the flow graphical example for classification. Regression. Regression models are used to predict a continuous value. Predicting price of a house given the futures of house like size, price, etc. is one of the common example of regression. It is a supervised technique. This is the graphical example for regression. Types of regression: linear regression, logistic regression, regression, lasso regression, polynomial regression, Bayesian linear regression. Linear regression. Linear regression attempts to model the relationship between two variables by fitting a linear equation to observed data. A linear regression line as an equation of the form y equal to a plus bx, where x is the explanatory variable and y is the dependency variable. Linear regression. The mathematical formula for linear regression is y equal to bx plus a plus c, where x is an independent variable, y is an dependent variable. A is the y-intercept, which is the expected mean value of y when all x variables are equal to 0. On a regression graph, it's the point where the line crosses the y-axis. B is the slope of a regression line, which is the rate of change for y as x changes. E is the random error term, which is the difference between the actual value of a dependent variable and its predicted value. This is the graphical example for linear regression. There are two types of linear regression: simple linear regression and multiple linear regression. If a single independent variable is used to predict the value of a numerical dependent variable, then such a linear regression algorithm is called simple linear regression. If more than one independent variable is used to predict the value of a numerical dependent variable, then such a linear regression algorithm is called multiple linear regression. The example for simple linear regression is y equal to beta naught plus beta 1x plus epsilon naught. Y is the predicted value of the dependent variable y for any given value of the independent variable x. Beta naught is the intercept, the predicted value of y when the x is 0. Beta 1 is the regression coefficient, how much we expect y2 changes as x increases. X is the independent variable. E is the error of the estimate, or how much variation there is in our estimate of the regression coefficient. This is the graphical example for linear simple regression. Multiple linear regression. Y equal to mx plus c, where y is the output of the model, which is called the response variable, and x is the independent variable, which is also called explanatory variable. M is the slope of the regression line and c denotes the intercept. This is the flow graphical example for multiple linear regression. Logistic regression. Logistic regression is another technique borrowed by machine learning from the field of statistics. It is the go-to method for binary classification problems techniques used to learn the coefficient of a logistic regression model from data. Log of p by 1 minus p is the link function. Logarithmic transformation on the outcome variable allows us to model a nonlinear association in a linear way. This is the equation used to logistic regression. Here p by 1 minus p is the odd ratio. This is the graphical example for logistic regression. Ridge regression. Ridge regression is a model tuning method that is used to analyze any data that suffers from multicollinearity. When the issue of multicollinearity occurs, least squares are unbiased and variances are large. This results in predicted values to be far away from the actual values. Lasso regression. In statistics and machine learning, Lasso, least absolute shrinkage and selection operator, is a regression analysis method that performs both variable selection and regularization in order to enhance the prediction accuracy and interpretability of the statistical model it produces. This is the formula and graphical example for Lasso regression. Polynomial regression. In statistics, polynomial regression is a form of regression analysis in which the relationship between the independent variable x and the dependent variable y is the model as nth degree polynomial in x. The general formula for polynomial regression is y equal to beta naught plus beta 1 xj plus beta 2 xj square plus beta p xjp plus epsilon naught, where beta naught is population regression constant, beta I is population regression coefficient for variable xj, j equal to 1 to k. P equal to order of the polynomial. Epsilon naught I is the model error. If P equal to 2, the model is a quadratic model. X equal to beta naught plus beta 1 xj plus beta 2 xj whole square plus epsilon naught. This is the flow graphical example for polynomial regression. Pressure versus temperature. Bayesian regression. Bayesian machine learning is a paradigm for constructing statistical models based on Bayes theorem. Bayesian linear regression allows a fairly natural mechanism to survive insufficient data or poor distributed data. It allows you to put a prior on the coefficient and on the noise so that in the absence of data, the priors can take over. More importantly, you can ask Bayesian linear regression which parts, if any, of its fit to the data it is confident about and which parts are very uncertain. This is the formula for Bayesian regression. Y of x comma w equal to summation j equal to 0 to m minus 1 w j phi j of x equal to w to the power t into phi of x. This is the flow graphical example for Bayesian regression. Thank you.